Hi my friends, today we model this part, which is, who can tell me, a piston, a regular piston, no more, no less. The suggestion about this piston was a drawing from Timoteo Carrera Soto, an engineer from the years 1950-60, and this page is in my site, where, as you can see, you find a page with Timoteo Carrera Soto, and this is a page from this brochure. You can download all these brochures and you will have many drawings there. This is a drawing with some dimensions. I made my drawing, which is this one, containing all the data from the original, but in a modern presentation. Okay, let's start. We start with the revolution body, which is here. 89 is the major diameter, 107 is the height. And we draw this contour to be ready for revolution. Dimensions are here, so we start by selecting the standard millimeters IPT template, and we draw a rectangle which must have dimensions near the ones in the drawing, like this. I apply center line to this line, 107, and a diameter of 89. Then the internal lines, as you can see, not very difficult, but very interesting. Next is a rectangle here, and we apply split to this line, this line, this line, because I want to make construction lines, these lines. Dimensions 6 millimeters is this channel, 6, and also 6 millimeters is the other one, 6. Diameters are 70, (82), also 82, different dimensions in the drawing, 80. This is 16. And this is 25. The thickness here is 6. Finish sketch. F6. We have a contour. We have a center line, so we can apply revolve. And we obtain directly the first volume. Yes, not a big deal. Anyone can make this. I apply aluminum 60AHC, and then we go to these details. A number of channels starting from up to bottom. 3, 3, 3, 3, 3. How many? Many. We'll create the first channel, this one, and then we apply rectangular pattern to multiply in 1, 2, 3 instances. Dimensions are 82 and 10 and 3. Okay, let's create this. What is the plane for the sketch? X, Y, the same as before. F7 to see inside a rectangle. I project as a construction line the external generator, and I make collinear these two lines. Then dimensions, this is 10, this is 3, and I use the axis Y to project as a center line, axis Y. Good. Y to place the diameter of 82 at the bottom of this channel, 82. Fully constrained. Revolve with cut, not join. Very simple and natural. Then we apply rectangular pattern for the last feature along the axis Y to the other direction. The number is 3 and the value is 6. The step between this is 6. Now you see what I have here. We go to the last channel, which is 6 millimeters, and we use the same plane XY. F7, rectangle. Now you know a lot. I project some geometry as constructive, and I disable constructive. I apply collinear here, and why not coincident this point with this line. Dimensions 3 millimeters is this, and 6 millimeters the other. Finish sketch. We don't have an axis because we didn't need a dimension inside. So I apply revolve by selecting axis is weight is expected here, yes? So I select the y-axis as before without projecting it in the drawing. Okay. Next feature is made of this cylinders, a rib, hole, and I will create one. I have to start from this plane to the part, not from outside. So I create a plane here, and then I extrude to the part, the contour. Dimensions are in the drawing. 44, 32 for the cylindrical part. Remember 32. We use not this plane, but this one as a base, because we need to create a plane with this base to the right at a distance of, you see here is plus, not minus. We don't have to place any sign. 32 divided by 2. Okay. This is the plane for our sketch. F7, and we draw a circle with a diameter of 44. It is placed, you see here, Z is horizontal, so I apply horizontal to select this plane, this point and this point. Yes, horizontal is vertical because this is vertical, Z, and a distance of 50 from the bottom, from the center point, 50. Finish sketch, extrude to next, and we have the feature visibility. Now I make a hole here. You see dimensions. I forgot to present the 50 here, and the hole is 31. 33 is this channel. 31 through. Hole face 31, center is this, and through. Okay, very nice. Now I want to create that rib. I use the same plane, and you must be very careful what I make here. I draw a line to be used as a base for the rib. You see, the only restriction or constraint is that the line to contain the center point of the circle. Only this? Yes, you are right. Only this. A simple line, not finished to the ends, and I apply rib, I select the line, and I have the rib. What is the thickness? 5 millimeters. Okay, you see, this is the construction. Good. Then I create the hole, the small hole in the bottom. You see, here is the thickness of the rib, 5, and the hole is a diameter of 3 millimeters at 11 from the face. This must be made by creating a plane at 11 millimeters minus 11. Okay. Then an axis at the intersection of this new plane with the plane XY, and we have the axis here. Yes, I hide this plane. Not work axis, the plane inside this. Then we create a point, work point, on this face at the intersection with this axis in this direction, not the other. Good. The 3 is diameter, hole. This point, we start with the point. This axis, not 31, but 3. Not this direction, but the other direction. Not through the part, which means it goes here, but to the face. What face? This face. Okay. I hide now the point. I hide also the work axis. We don't want to see other elements in our model. Now I apply mirror, my friends. Oh no, let me create a channel here. There is a channel, this one, which has 33 diameter, 1 millimeter width, and 22 from the face. How can I do this? By revolving or by extruding a circle with 33. I prefer to revolve. The plane is XY, F7. I go inside, I project geometry, this line, no matter that it is not construction, because I create a rectangle, and this rectangle is the only closed area. The dimension 1 millimeter, not 12 but 22 from the left, and the diameter, to have a diameter I need to create a line here. I create a line starting from the midpoint to somewhere. I don't want to place a dimension, so I make that this point to be on this line. You see? If somebody moves the channel, we have that line. This line is center line, dimension is 33 diameter. Okay, fully constrained. Revolve, cut, everything is there, so I can apply OK. See, this is the channel. Now I make the mirror. Mirror of what? Mirror of this extrusion, this hole, the rib, not work point, not work axis, hole, and the last revolution. About what plane? About this plane. And I must see here something. I see, my friends. I see what happened. What happens. Okay. Very nice. Next are a lot of holes, 28 holes in the middle of the two channels with dimension of 6. 6 is here, 6 is here. You see, this is the middle, not up, not down, in the middle, on vertical. You see, we have 7 holes, diameter of 5, starting from this axis at this angle from here to here is 90 minus 3 or 20, which means 30, but I don't write 30. I write an expression when I have to do this. How to create this first axis, to create the first hole, and then to multiply on a polar pattern or circular pattern, we create a plane, we intersect with another plane at a certain level, and then we have an axis. We'll create a point and then a hole. This is my proposal for the first hole, and then we multiply it. Let's start. I create a plane, as I said, based on this plane and this axis, and I rotate. You see the position, yes, 90 degrees here. I rotate this to be at, to have here a small distance, yes, and this means that we can apply 3 multiplied by 20 degrees for that position. Good. Now I create another plane, the mid plane between the two faces of the channel. This doesn't need to use mid plane between two planes, because is by default that if you select two planes to obtain the mid plane, as you can see. Now at the intersection of these two planes, I create an axis. I select one plane, I select the other plane, and I have the axis. Then I hide these two planes because I have the axis. I create a point at the intersection of the axis with this face. Having an axis and a point, we can apply hole. Hole from this point, this axis, diameter of 5 millimeters, okay, but not through. The end must be this face. Okay, this is not okay, but let me show what happens. Okay, the axis not visible, the point not visible. What is the problem? I said there is a problem, but wait for me to finish all the 28 holes. We multiply the hole in a circular pattern. I select the last feature, which is the hole. I select the rotation axis, and the number is 7 number of occurrences, and the total angle is 6 times of 20. You see, this 7 divided from 6 multiplied by 20 degrees. Okay, we have a first result. They are symmetrical. Symmetrical from this plane. Good. We apply mirror of all these holes, mirror of the circular pattern together with the first hole. You see? Which is the mirror plane? XY. And we'll find these 7 holes there. Okay. Then I create a midplane between this face and this face to mirror again above that plane all these holes. Oh, what a complication. Not any complication. One plane, another plane, and I have the mirror plane. What to mirror? I mirror the hole, the circular pattern, and the mirror of them. What is the mirror plane? The mirror plane is this one. Good. Okay. I hide the mirror plane and I take a look from the bottom. Very slowly. What we see here? We see some cuts. Why these cuts? Because every hole goes to the other end of the face, of this face, and it not stops here. What to do now? Well, now I modify the depth of the hole. If I change something to the seed, this hole is the seed for our multiple mirroring and circular pattern. So I edit this feature. You know that the wall of the piston here is from 82 millimeters to 70. Yes, so I can create that depth for the hole, and I will avoid that unwanted cuts. I stop this to find the dimensions, the parameters for 70 and 82. They are in this sketch. Yes, it was right. So, and we have here 80 and 82 and 70. I don't go to the parameters. I go here and I select expression. What I see here? I see that D6 is 82 and D4 is 70. Yes? So, if I subtract 70 from 82 and I divide this by 2, I have this wall. But in order to have no problems at the end, I'll add 1 millimeter D6 and D4 to be remembered in this order. I subtract from D6 the parameter D4. I go to the hole, double click, and I select distance, and the distance is D6 minus D4 divided by 2 plus 1 millimeter to the inside, and I'm sure that the hole is through the wall. Okay. Changing the seat, I change all the 28 holes. Look here. You see? No problem. The hole is finished 1 millimeter from the center to inside. Good. It seems to be finished. No, it is not finished. We have to apply a lot of fillets here. And if you take a look to the drawing, you see that 1 millimeter is here. Oh, this is a mistake. This one must be deleted because 1 millimeter is this. My fault here. I apply a radius 2 in another place in order to have a dimension of this, because this is 2 and the other are 1. Oh. I go here or here. Yes, this is 1 and the rest of them are 2 millimeters. 2 everywhere. And there is another one here, not placed. Let me place it in the other hand. Radius 1 is also this one. My friends, I repeat, I'm a human, yes, not a robot, not a machine. I make mistakes. I'm sorry, but this is the reality. And the age has its word to say. Radius 1 inside, radius 1 here, and the rest are 2 millimeters also here. Let's apply all these dimensions. 2 millimeters is by default, so I start with that of 2 millimeters. But what can I find every point here? Every corner. I'll make something for you. I create a new view with the half section view by moving this plane here, and now I have another view to every corner. Good. This is 2. This is also 2. This 2 and this 2. The other at the bottom, other at the bottom. These 2 faces and here the bottom and 2 times, and this once. I suppose that's all. Yes, That's all, my friends. Okay, now I go back with the half section view and section view to apply 1 millimeter. I select this with the value of 1, not 2, and the other one I'll see if I look from the hole, this one, and also this. Normally the part is placed so, and that's all. Okay, F6. As usual, we must apply eye properties to the part, eye properties, to see what is the volume, and you see here the volume. Copy, close, we go here, double click, and the new value is smaller than this one, which means that we have to respect the last one and to delete the previous one. Okay, what we did is respecting the drawing and having a volume. If you respect the procedure, you have the same, you'll obtain the same value, I guarantee. With this, I finish the modeling. I wish you a happy new year 2022 to you and your family. Thanks for watching. Bye bye.